Okay, what we're looking at here is a piece of thermocouple wire. This right here is type J. We can tell that from the color code, white and red, with red being negative and white being positive. This right here is thermocouple grade wire. You can tell that from the brown sheath. And if we simply took these two wires here and twisted them together, or spot welded them, or otherwise clamped them, or silver soldered, that itself would form a thermocouple junction. We could then connect the other two ends to a thermocouple instrument and have ourselves a working sensor. This is how simple a thermocouple can be. It's nothing more than a pair of dissimilar metals of specific type joined together to make a junction. Now, this is one way to make your own crude thermocouple. However, you can buy pre-manufactured thermocouples such as this one. This one right here, made by Omega, this is a type K thermocouple, chromel, alumel. You can tell it's a type K both because it's labeled there with a letter and by the color. This is matching the sheath color of the thermocouple, and yellow is type K. You can also tell this is a polarized plug. The positive plug is the skinnier of the two, the negative is the fatter of the two, so they're hoping to make it so you can't put it in backwards. This goes into a matching thermocouple plug, like this one right here. You can see here the two hole sizes. We have a fat one and a skinny one, goes in nice and easy. If you try to put it in the other way, it doesn't want to go. However, never underestimate some people's ability to force connectors where they shouldn't go. I've seen thermocouple connectors shoved backwards like this, where someone, you really got to wonder about the person, but they put a lot of force in here and they actually managed to get it in. But it's supposed to go in like this, a polarized plug. So that's a type K with a pre-molded plug. And as I mentioned before, that thermocouple I was holding on to, that little piece of type J wire, is a homemade thermocouple. All we have to do is twist the ends together and voila, we have one. We also have another version of an industrial thermocouple. This one right here does not have a molded plug. It just has two wires coming out, but we can tell from that it is also a type K, yellow and red, red being negative, yellow being positive. Now the question was asked earlier, can we tell if this is grounded or ungrounded? You cannot tell that visually. You can only tell that with a meter. The difference between a grounded and ungrounded thermocouple is internal, and you cannot see it without cutting it open. We would have to take an ohm meter and measure for continuity between either one of the wires and the stainless steel sheath in both cases. However, we know that in both these cases they are not an exposed tip. An exposed tip would be obvious. You would see the thermocouple wires jut out with a little blob at the end where they're welded together. You don't see that here. These are both covered tips. They're sheathed by stainless steel that protects them from the ravages of the process. It also slows down the process response. And to tell whether these are grounded or ungrounded, again, we would have to take an ohm meter and do continuity checks between either wire and the stainless steel sheath. But these are pre-manufactured industrial thermocouples here, both type K, and then the one I was holding before, that little piece of wire there, was just a type J wire. You can form your own thermocouple by twisting the wires together.